All right. So at this point, we've seen the two expressions or two ways in which you can look at a straight line linear equation, meaning the same thing. Now we're going to look at solving two equations. We're expecting three different things to happen. So I'm going to deal with those three different things as three different cases. Okay, first let's say we have these two linear equations to solve. 2x plus 3y equals negative 7, 3x minus 2y equals 4. Now, what is my goal? Goal 1 is to eliminate one of the variables. Okay, I want to eliminate one of the variables, and how do I achieve it? Is I make the coefficients same or equal by multiplying what's missing. And then the second goal is much simpler. Solve the resulting equation. This is much easier. And let me explain what I mean. So here, let's say I decide to eliminate x. Okay, I notice that in the first equation it has the coefficient 2, and in the second equation it has the coefficient 3. So I go ahead, I want them to be equal, so I'm going to multiply the first one by the second's coefficient, which is 3, and the second one by the first coefficient, which is 2, and I'm going to rewrite. When I rewrite, this is going to be 6x plus 9y equals negative 21, and 6x minus 4y equals 8. Now that these are the same, in order to eliminate them, I'm going to subtract. When I subtract, I have to be careful about the signs. So one way to keep track is using parentheses. So if it's positive, it becomes a negative, and if it's negative, it becomes a positive. So 6x minus 6x is 0, they cancel out. 3y plus 4y is 13y, and negative 21 minus 28 is negative 29. So y comes out to negative 29 over 13. That is half the solution. Okay. So this is, remember, note, not yet complete. Why? Because all you did was you found a y value. You haven't found the x value. So we need to find x. So let's see. To find x, I'm going to go 2x plus 3 times negative 29 over 13 equals negative 7. That gives me 2x minus 87 over 13 equals negative 7. 2x equals 87 over 13 minus 7. That's 13 negative 4. So x is negative 2 over 13. Don't worry about these being slightly complicated fractions. What is important is the process. So we say that the solution is x equals negative 2 over 13, y equals negative 29 over 13, or recalling the coordinate system, writing as ordered pair, I can write it as negative 2 over 13 comma negative 29 over 13. And what is that? That's a point. So this corresponds to the picture being that of two straight lines. That's not something like that. Since they're both negative, it's going to be in the fourth quadrant. Okay, so the case 1 corresponds to the situation where when you draw two lines, they meet at a point. And where is that point? That point is exactly negative 2 thirteenths and negative 29 thirteenths. Let's look at case 2. Case 2 says 2x minus 2y equals 3 and x minus y equals 2. So I notice here that I can make the coefficient of x the same simply by multiplying the second one by 2, which leads me to 2x minus 2y equals 3 and 2x minus 2y equals 2. Now here, what's going to happen is when you subtract, you're going to end up with something bizarre, because these cancel out and you end up with 0 equals 1, and that is surely not true. So what happened here is that you end up with something that does not make sense. So what we say is that there is no solution. And as picture, this corresponds to parallel lines. Okay, in fact, you can try it out. 2x minus 2y, or let's start with x minus y. So if you construct the table for x minus y equals 2, right? You just need 2 points. So let's let x be 0, then y is negative 2, and y is 0, x is 2. So that's 1, 2 comma 0, and 0 comma negative 2. So that's my line right there. And then let's say the other line is 2x minus 2y equals 3, and again I construct the table. Just need two values. When x is 0, this is negative 3 halves, and when y is 0, x is 3 halves. So you have 0 comma negative 3 halves somewhere here, 1.5, and 3 halves comma 0. So the yellow line and the blue line are never gonna meet. So if you end up with something bizarre, namely something that you know for sure is not true, then it's a no solution case. Case 3 now. Again, I multiply this by 2 and I rewrite as 2x minus 4y equals 8. In this case, as soon as I subtract, I end up with something, everything cancels out, but I still end up with something that is true. And not just true, I end up with something that is always true. Meaning it does not depend on x or on y. So what this means is that there are infinitely many solutions. Why? Because they're the exact same line. They're both 2x minus 4y equals 8. They're just factored down. So it's like saying the number 4 is the same as number 8 over 2, or the fraction half is the same as 6 thirds, etc. 6/3, 3/6, sorry. So on the graph, this is the case where you have corresponds to the coinciding lines. Okay, so those are the three cases that occur, right? So the three cases that occur is: 1, if they intersect, then you have one solution, which is precisely the xy that you find. If parallel, then you're going to have 0 solutions, and you end up with a false statement. And then lastly, if coinciding, then there are infinitely many solutions, which means we end up with an always true statement. Typically, what would happen is you end up with something like 0 equals 0. And in the previous case, you would end up with something like 0 equals -1 or 0 equals 1 and so on. That's it for this video. So what we have shown here is a method to solve system of equation, and then also how to interpret those results in accordance with what we saw before, which is the three possible cases of one solution, no solution, and infinitely many solutions.